So hi everyone, welcome to another video section of my YouTube channel. So I'm still your host. My name is Mayowa Owolabi. So what I'm trying to achieve today in this video, or what you'll be learning at the end of this video, is um, we're going to use how to use some Excel tools. All right. So then we're going to be running some statistical tests on a set of observations. Okay, so let me just uh, give you let me just show you the data. Okay, so here um, we started our Facebook page EMF research in March, and it's been 4 months. This is June. So you have this data was actually extracted from our Facebook page EMF research, where we offer consultancy, thesis writing, um, statistical data analysis to international students. So if you're an international student and you're trying to get help on your dissertation, your thesis, we can do that for you. We can be of assistance. So, and we assure you that our work is 100% plagiarism free, and we don't use we do not use artificial intelligence to do some of our work, and we have very good results. We have outstanding. Some of our feedback has been great, and okay, so let me just this is a work for one of our PhD students. This is one of the work we just completed, and as you can see, this is a table of content. You can see the list of tables and tables of figures. You can see introduction, and you can see just look at the quality of the work we produce at EMF Research Consult. Okay, you can see so this is just a research plan for a PhD thesis. Okay, you can see, I'm going to show you the references. You can see, so this is upper style of referencing. And okay, so don't let me deviate from what I want to achieve from this video. So this is not what we want to do today. Okay, so this is the data set of observations. So you have the month, that a month, and the engagement. All right, so this, for each of these months, represent the content, some of the posts and contents that we post on our Facebook page. So this is the numbers of engagement, how people have actually reacted to that post. All right, so this is data we're going to be using, and we're going to be running. We are going to be doing some things on it. So I believe you gain so much knowledge after watching this video, and I know. Okay, so let me just give us a breakdown of some of the things you learn. So you learn how to use pivot table and SLICER. All right, so pivot table is when you want to aggregate a set of data. Also, SLICER does similar thing, but a little bit different. Okay, so then you have univariate analysis. We are going to be running some measures of central tendency, position, dispersion. We are going to be looking at graphs, histogram. We are going to be plotting the box plot. Okay, so then we are going to be looking at test of normality. All right, we want to know if the set of observations are normally distributed. Do they behave normal? All right, so 3, we are going to be looking at, okay, 4, we are going to be looking at the runs test. So what is runs test? All right, when you have a set of observations and you want to know if these observations, their arrangements, are they random or not? All right, so runs test is a test of randomness. Let me say that. Okay, so we want to know if this engagement are they random? You can see that they are increasing. All right, yes, data is increasing, and you can see the highest engagement we have is 120 engagement. It means 120 people actually reacted to a particular content. All right, so let me go back to the board. So the last thing we're going to be doing is to run analysis of variance, which is ANOVA. So what does ANOVA do? All right, so we use ANOVA when we want to compare, you want to test for significant difference, mean difference. Yes, we want to test for significant mean difference between 3 or more groups. Okay, now if you look at the data, we have 4 months. All right, so we can categorize the months as groups. So we want to see the engagement that we have. Is there any difference between the engagement or not? Then we cannot draw some conclusions and say, okay, probably in the month of March, the engagement that we have between the month of March and May or April, there's no difference. All right, the engagements are not really doesn't really have any difference, like does not really make any meaning. All right, but if we have significant difference between the groups, then you can actually say, okay, probably we are doing something right. Okay, some of the engagements that we've had have come through some of the great or good content that we are actually pushing out. Okay, all right, so we are going to be using 2 softwares. We're going to use the Microsoft Excel and the STATA. Okay, so let's get to it. So I'm going to look at the pivot table. All right, so if you go to insert, you see the pivot table here. Okay, so this is telling you that you have to highlight your data range. Okay, you highlight your data. Okay, so when you highlight your data, you come here and you press OK. Okay, so you can see the pivot table fields. All right, so I'm going to drop this month. I'm going to carry it and drop it inside the column. The engagement, I'm going to drop it in the values. All right, so let me look at the what we have. Okay, lovely. Okay, so as you can see, we have the months. We have 4 months. We have March, April, May, and June. So in the month of March, we have 105 engagements. Then, as you can see, the last month, which is June, which is the current month that we have 1,238 engagements. Okay, so that is what this is one of the information that. Okay, so if I put, let me say I put this month, I want to put it in the row. Let me see how it look at. Okay, lovely. So you can see how I think I prefer this. Okay, so I'm going to look at the SLICER. What can SLICER give to us? Oh, all right, so let me close this. Okay, so let's see the SLICER. Okay, so I'm going to click on the month and engagement and see. Yes, so this is the SLICER here. We can see, so we have the month and the engagement. So if I click, so what it does is just to aggregate the engagement. Those ones that are meant for March, it will aggregate it to March. You know, if you look at data here, it has been disarranged. All right, you have May here. Then if I scroll down, I think you see have other. You can see the data are scattered. So SLICER will help you to aggregate the data. So this tool can be used in the business world. All right, when you have a sales data or a business data, so it is very useful. So once you click on match, you can see you have the data has been highlighted. So you have just 4 data in March, in the month of March. Yes, so if I click on April, you can see these are the set of observations. In March, in May, these are the set of observations in May, as you can see. So the ones that are highlighted are the ones that are meant for May. So June, you have the same thing. Okay, so I think we've already achieved two things now. Alright, we've looked at the pivot table, what it can actually give to us. Then we've looked at the SLICER. So these two data, so you can see, let me now, so I think I've separated the data so you can see this is the data for March. Alright, the data for April, May and June. So you can see these are the data. We've actually separated them into their months. So this is important so that we can run our univariate analysis. Okay, so we are going to move we are going to look at, so we are going to open the STATA and let's see. Okay, so this is the STATA package. Alright, so you can run statistical tests on STATA, you can run financial and econometrics, you can run medical statistics on this same software. Alright, so I will teach you how to input data. Alright, before I open the data I already have, so you go to the data editor. Okay, so this is the data editor. So you can see this is the you have the data view here and you have the variable view. Alright, so this is a little bit similar to SPSS, but they have I think STATA has more robust statistical tests than SPSS, if I will say that. So but both of them have their very good packages, either of them that you want to use to run any of your data sets. Okay, so let's start. Okay, so let's say I want to have some set of observations. Let's say I have 10, 20, 30. Okay, then I have 11, I have 12, I have 14. Okay, so this is you can see this is the if you look at the row, you have the first column, you have variable 1. Alright, so this is variable 1. Okay, you can see it has been marked. Then you can change the name of the variable here. Let's say this is class A. Alright, this is the first class. Okay, you can see it has been changed there. So if you look at the second one too, I can change the name here. Alright, let's say this is class B. Okay, so let's assume these are the numbers of students in two different classes. We have class A and the class B. So this is how you input data on STATA. Okay, so if you want to run any package, you want to run any statistical analysis, you have to go to your where you have the functions, some of the tabs. Alright, you can see the graphs, you have the statistics, you have the graphs, you have so many things. So let's say if I want to run a bar chart, a simple bar chart for these two data sets, let's see what we can have. Alright, Okay, so let me just okay, so this is what okay, let me see. So let's see what we have here. Okay, so you just need to set some of the parameters. You have to set it well. So let me just, that is not what we want to do anyway. So let me close this. So you've seen how to input data on Stata. So let me just go to data now. Data that we have. Okay. So let me hop on. So I think the data has been loaded. Okay, so you can see. So what I'm going to do, I'm going to copy. So these are the engagement, all right, and this is a factor, because if you want to run analysis of variance, you have to factor some of the groups. All right, we have 4 groups. So match has been assigned as 1. You can see these are the data for March. Then 2 has been assigned for April. Then we have June will be assigned as 4. Okay, so you have to factor. Let me see if I can bring out some of the uh, if I can show you some of the okay, so let me just okay, so let me just do it now so that you see. March 2 we have to stay as so now you can see we now have if you want to check, so you go to data, you go to the values, you manage the you can see. So this is now this is a factor now, because we have 4 groups and you have to represent each group with a factor, right? So I need to have I want to have the set of observations, I want to have them separated. So I'm going to go to the Excel to go and copy the data. So I'm going to copy this data now. Okay, so I'll copy, then you go to your Stata and you copy. Okay, so this is, so now I need to change some of their variable name. So you have March, okay, you have April, May, then you have June. Okay, very good. So these are the variables. So what we will now to do is that I need to run some univariate you want to run some univariate analysis. All right, so if you want to run some of the analysis, you go to your you come here, then you look at statistics. So you look at the summary statistics. Okay, so I have to select some of these variables. March, okay, select April, May and June. Okay, so let me display additional statistics, then you press OK. All right, so very good. So this is the data for March, April. So let's see more. Okay, so this is the other so for March, if you look at this, is a how many set of observations do we have in March? We have 5. Okay, this is the mean. We have 21. So in the month of March, we have an average of 21 engagement. Okay, so this is the standard deviation. We have the variance, we have the skewness. Okay, we have the kurtosis. Okay, so then you have the percentiles here. All right, we have percentiles, and then what do we have? Okay, so this is it till June. Okay, so I think the highest average should be in May. Okay, so May has an average of 58.5. Let's see, approximately that is 59 engagement. Okay, so sorry, that is June. Yes, so the highest average engagement that we have is in the month of June, which is 77 views or 77 engagement. Okay, so let me run the box plot. Let me see how the box plot will look like. So I'm going to run the box plots March, April, May, June. So let's see. So nice. It's nice. So let's see. Let me just expand this a little bit. Okay. So very good. So now the box plot will give you 5 information. It will give you the smallest value in the observation. It will give you the first quarter, the second quarter, which is also the median. Okay, it will give you the third quarter, which is Q3. Then it will give you the last one, which is the largest value, or the largest observation in that data set. Okay, so if you look at June, we have some extreme values here. We have 2 extreme value, you can see in June. So had it been this data, there has been some errors in this data. You can look at it, you can go back to the data in Excel and check if we've not made any mistake. But because this data was actually extracted from Facebook, okay, so we can't say this is we can't say this extreme value will influence our analysis, because this is the accurate data that we got from Facebook. So you can see, so this is the first the minimum value in the observation. This is the minimum value, then this represents the Q1, this represents Q2, this line, which is also the median. This represents the Q3, which is the third quarter. Then we have the largest value in the observation, which is, we can say, is 120. Okay, so I'm going to close this. So what, let me see, what univariate analysis can we still run? Okay, okay, let me see, the let me see okay, let me look at the graph. Let me see if we can get something. Okay, let me look at the histogram. Yes, let us look at the histogram for each data set. So we have, okay, so I think we can't, okay, I think we have to create it one after the other. We can't create it at the same time. Okay, so let me see the histogram for March. Okay, so this is the histogram uh, for, because there's um, just 5 set of data, 5 observations from in March. So I can't really, we can't really deduce so much. We can't really say if the data is skewed to the left or right, because the data is not, the sample is very small. Okay, so let's look at the data that has very large sample. Let's take, for example, uh, let's look at May. Okay, yes, so if you look at this data now, okay, let me look at the data view. Yes, we have largest sample in May. So this, okay, so this, I can say now that, okay, this set of observations, they are not normally distributed. All right, this uh, distribution is actually skewed a little bit to the left, so I can say a little bit that, okay, with this observation is skewed to the right, a little bit skewed to the right. All right, so but it is not a normal distribution. Okay, so I think we've been able to achieve how to use pivot table and SLICER. We've run some univariate analysis on the observation. So now let's go to test of normality. So, but I'm not going to run the test of normality on each variable. So I'm going to do it on the whole joint observations together, the combined observations. So for the test of for the test of normality, we are going to look at the one sample Kolmogorov. Yes, the Kolmogorov test, which is for test of normality, to see if the set of observations are normally distributed. All right, so we are going to see, let's say, okay, I think it should be here. Yes, yes, so this is one sample Kolmogorov or Smirnov test. All right, so this is, so we are going to insert the table, the variable, which is the Facebook engagement. Okay, so okay, so what is this information telling us? Okay, invalid syntax. Okay, so let me see. Okay, let me just try it on any of the. I don't know why it's not. I don't know why it's not running. It's still bringing out. Uh, okay, so let me just look at the histogram for the old data set. Let me see. Let me look at the histogram here. Let us observe the histogram and see how it will look like. Okay, so you can see this data is not a normal, does not look like a normal distribution. It's a right skewed distribution because it's kind of skewed to the right. All right, if you look at the graph, this is how it looks like. Okay, so it's skewed to the right. Okay, so I don't know why. uh, Let me see if I can find an alternative to run the test of normality. Okay, Komogorov test. Let me see. Okay, I don't know why it is not still working. Okay, so I don't know why it's not working, but we are supposed to have a result for the test of normality. So the test of normality, the null hypothesis is the test of hypothesis is actually this is the test of hypothesis. So the distribution is normal. All right, so that is the null hypothesis. Then you have the alternative, the alternate hypothesis, as the distribution is not normal or does not come from the set of observations does not come from a normal distribution. So when your the p-value, which is the probability value, is actually uh, greater than 0.05, okay, when your p is actually greater than 0.05, then you can say the distribution is normal. Okay, so that is for that. So let's look at Ron's test. Ron's test. Ron's test. So you have uh, the null hypothesis. So the Ron's hypothesis for Ron's test. So Ron's test is saying that the distribution is random. Okay, the distribution is random, or you can say the set of observations is random. Okay, so let's look at the runs test. So I'm going to look at the runs test now. So this is the test of the runs test of random order. So I'm going to look at the variable. I'm going to pick. Okay, so I think you have to leave all this. Very good. So you can see the runs test. You have so this is the run test here. You have the observation 53. So this is the run statistic, which is 6. All right. You have the z table. This is coming from the table of the runs table. We have minus 5.96. Then this is the probability, which is the p-value, which is 0. So this value is actually less. All right, this value is less than 0.05. So we can say that the distribution is not random. So all right, so we can now say that, okay, the set of observations or the engagements we've been having, if we want to draw a conclusion, we can say that the distribution of that observations, they are not random. They did not occur due to random chance. All right, people actually engage them based on how because if you look at the engagement, you see that, let me show you the table. You see that the observations keep increasing. All right, the observations of the engagement keep increasing. All right, so it tells you that the observations, people are engaging it as because of the good content, let's say, hopefully. Okay, so the last thing we're going to do here is to look at the analysis of variance, to conduct the analysis of variance. So we're going to we're going to come here. So we are looking at the one-way ANOVA, the one-way analysis of variance. Okay, so we are going to look at the response variable, the Facebook, then the factor. We are going to come here and insert the factor as the factor variable. So we are going to run some multiple comparison tests to see the difference. All right, the difference between the groups. So anyone you pick, the Boni Ferroni, the Sheffield and the CDAC, they all do the same work. All right, so you have to just press OK. Okay, lovely. So if you look at before then, let me just write the null hypothesis for the analysis of variance. So null hypothesis. So you have there is no significant so there's no significant mean difference. All right, between the groups. Okay, so this is your null hypothesis. So once the p-value, all right, if the p-value is greater than 0.05, then you accept the null hypothesis. But if it is less than 0.05, the probability value, then you can say that the mean difference, there is a difference between the engagement we have in March, April, and up to June. Okay, so we're going to run. So now let's interpret the table. So you have the analysis of variance table, you have the between group, you have the sum of square, you have the degree of freedom, you have the mean square error. All right, we have the F statistics, the Fisher's statistic, then we have the p-value. So this, you can infer from this table, you can see that the probability value of the ANOVA is actually less than 0.05. You can say the table is significant for the difference. All right, the ANOVA is significant. There are significant difference between the groups. Okay, so there's a difference. Then if you look at the comparison, the mean difference, all right, the multiple comparison test, the Bonferroni test, if you look at it, so this is the for the difference between March and April. All right, you see this is the difference. All right, so it means the engagement we have in the April is more, is 26 times more than what we have in the March. All right, so the difference is not significant because this p-value is actually greater than 0.05. So if you look at in May, and March is not significant. May and April is not significant. All right, if you look at the June and March, it is significant. All right, because this value is less than 0.05. So there's so much significant difference. There's a mean difference between the engagement in March and that of June. Okay, so if you look at what we have in June against what we have in April, there is no significant difference because this value is greater than 0.05. Same. So the only significant difference we have, the main difference, if you look at within the groups, is just between the June and the March. All right, but overall, the overall conclusion that we can draw from this statistical test, which is the analysis of variance, is that there is significant difference, there is significant mean difference between the groups. Okay, so I think we've been able to achieve some of the things we want to achieve. All right, and hopefully, okay, probably let me just add the statistics SPSS. Let's see if SPSS, we can get results from SPSS so that we won't because we've not been able to achieve the test of normality. Okay, so let me just go to SPSS. Let me open the SPSS. Let's quickly run the SPSS version and see. Okay, so let's just give it some few seconds to. All right, so it's coming on. Okay, so I'm going to type in data. All right, so let me just. Okay, so I don't think I need to fill any more data. Okay, so let me just copy the engagement here. I'll go and copy that from. Okay, so let me copy. Okay, so you can see, let me just reduce the decimal point. I don't want decimal point. Okay, so you can see this is the data view in SPSS, and this is the variable view where you edit some of the characteristics or properties of the data you want to enter. Okay, so what we want to run now is the test of normality, which is the cosmograph. So let me see. Yes, so this is the one sample cosmograph test. So I think we should be able to get what we want. Okay, so the normal has been, so you can see the test of distribution for you can check that of Poisson distribution, that does this observation uh, does it look like a Poisson distributed observation, or is it in uniform or exponential distribution. So I'm going to click OK. Yes, so I don't know why it's not working on STATA, but you can see on SPSS you have the number of observations as 53, you have the mean, alright, the mean of all the observations, we have the standard deviation, then so look at the cosmograph. This is the cosmograph statistic, this is 1.249, then this is the p-value, which is 0.088. so this value is greater, alright, is greater than 0.05. So we can say that the distribution of observations is normal, alright. So our observations are normally distributed. You can see, so the results we have here, I'm going to write it out. We have p, so the p value we have here is 0.088. So for runs, the p value we have is so you have 0. Okay, so we have 0. All right, so look at it, and you can make decision using this okay. All right, so if you look at test of normality, this is the null hypothesis, the distribution is normal. Okay, so looking at this value, our p value is greater than 0.05. It means we have to accept the null hypothesis. So let me just state it fully. If p is greater than 0.05, then we have to accept the h naught, which is null hypothesis. Otherwise we reject the null hypothesis. Okay, so same thing goes for this. You can see this is 0. Okay, so this is 0, and the runs test is telling us that the distribution is not random, because this value is less than 0.05. Alright, 0.05 is actually greater than 0. Alright, so I think we've come to the end of the video tutorial section. So thank you very much for your time. If you've really learned something, you've gained something during the course of this video, please make sure you subscribe to my channel, and you can also go to our Facebook page, EMF Research. You can like our Facebook page. You can follow some of our content. We share content on research methodology, we share content on the research design, statistical tests, and so many other things that you can learn from. Thank you very much. Thank you, and bye bye.